All right, folks, so today our lesson was on solving one-step equations. So yesterday we learned about the guess and check method, and it works. It works fairly well for really simple cases, but sometimes it's not very efficient. And you probably found that yesterday when we started to get numbers that were larger, that you had to make several guesses before you actually came to a guess that was the correct answer. So another example would be, let's say I had an equation like this. Now with these decimals I could spend a lot of time trying to do some accurate guesses in order to get my answer. And I also see that I have an x over here and an x over here, which further kind of complicates things. The reality is that if we use a systematic approach, that equation would not be difficult to solve at all, and I could probably easily solve it in under a minute. And by the end of this semester or this year, you will probably know how to do that too. We'll have learned about that. So here are the basics. Okay, so whenever we're solving an equation, an algebraic equation, the goal is always to get the variable, that is the letter, all by itself on one side of the equal sign. Okay? There's a special name for that. That's called isolating the variable. When you isolate something, you get it all by itself on one side of the equation. So for example, if I'm looking at x plus 2 equals 7. Now remember, we can easily look at this and guess and check, but we want to develop a systematic approach. Okay, a system of steps to use that we can apply to even the hardest questions, even the more complicated questions with large numbers or decimals. So try to avoid using guess and check with this. Okay, so in order to get our variable x all by itself on one side of the equation, that means that we need to get rid of this plus 2. So how are we going to do that? Well, we're going to take away 2. But the thing that we need to remember is that, this is an equation. So that means that the left side should equal the right side. So if I take 2 away from the left side of the equation, I really need to take 2 away from the right side as well, so that I keep the two sides in balance. So now I can start to work this out. Okay, when I take the 2 away from the plus 2, then that's going to leave me with 0. But I need to drop this x down as well, just because it's still there. I haven't done anything with it. Now I need to do the same thing to the right side of the equation. So I have my 7 minus 2, and that gives me 5, so I drop that down. Now I'm almost there. You should know that when you add 0 to x, I really don't change x at all, so I can simplify that even further and reduce it to x equals 5. So there I've solved this equation by getting x all by itself on one side of the equation, and then all of the other material I've moved to the other side so that I could get an answer for what x stands for. So like yesterday, I can always do a check to see if I've made any mistakes in my steps. And here's how you do that. So I take my original equation, the x plus 2 equals 7, and I'm going to go ahead and substitute in the value that I got when I isolated x. And I'll place that in the equation wherever I see the variable. And when I do that, I see that I have 5 plus 2, and 5 plus 2 is 7, and my left side equals my right side. So I'm in good shape, and I've done the question appropriately. So now we're going to go through 3 more examples to help us out. But before that, let's go over some more basics. So in order to isolate a variable, to get a variable all by itself, I need to get rid of all of the other stuff that's around it, okay, be it constant terms or coefficients. And so to do that, I always perform what we call the opposite operation. Okay, so you have to undo what you did. So just like in the first question where I had plus 2, I undid the plus 2 by taking away 2. So the opposite of adding is just subtracting. We haven't seen examples where we're using multiplying yet, but we need to know that the opposite of multiplying is, of course, dividing. Okay, and again, we'll see this sometimes. The opposite of squaring, to undo squaring, we take the square root, and we saw that with Pythagorean theorem type questions. So now I think we're ready to start our first example. So you may want to pause the video to give this an attempt, or you may just want to watch this first example to make sure that you're on the right track, and then try the subsequent ones. So I see that I have -6 here, so that means I need to take the -6 away from this variable to get that x all by itself. So I'm going to add 6. But again, I need to make sure that whatever I'm doing to one side of the equation, I'm doing to the other side to keep things in balance, to make sure that my left side still equals the right side. And so if I do the same operation to both sides, I haven't really made them unequal. So now I want to make sure that I can add these together to simplify. So my x will just drop down. I know that -x plus x will give me 0. And then my 8 plus 6 will give me 14. And again, I want to simplify that further, and I get my answer of x equals 14. All right, so let's try the second example. Again, feel free instead to pause the video, try the question yourself, and then check it. So I'm going to subtract 7 in this case because my variable y, even though it's second here, it doesn't matter. Okay, I want to look and see, well, what's beside my y? It's a 7, but the 7's positive because there's no sign indicated. So that means that I need to take away 7. Whatever I do to one side, I'm going to do to the other. Now I'm ready to start simplifying this. So when I take my 7 minus 7, I get 0. My plus y, I didn't add or subtract anything from it, so it remains as a plus y. On the right side of my equation, I started with 2, but then I took away 7. So this is where you may want to double check with your calculator because we are going to be looking at some negative numbers at times. So 2 take away 7 gives me -5. And a good way to think about this if you're going to do this mentally is if the temperature outside is at 2 degrees and then it drops by 7 degrees, then the temperature that I'm experiencing outside is -5. So now I want to simplify this. And so I'm going to get rid of that 0, and I end up with y equals -5. And that's it. All right, next question. So when I look at this, I'm seeing that my variable is on the right side of the equation instead. That makes no difference in how we approach this. We go about things in the same way. I look to see where my variable is, and whatever is beside it, I want to take away so that that z is all by itself. So because I'm subtracting 9, in order to get rid of it, I'm going to perform the opposite operation. I'm going to add it in. But whatever I do to one side, I need to do to the other side. Adding everything up, I see that my -9 plus 9 gives me 0. I didn't do anything to z, didn't take away any z's or add in any z's, so the z just drops down. Then I have 9 plus 5, which gives me 14. Simplifying that again, z equals 14. Now it's always good practice in math in terms of format to do a couple of things. You'll notice that throughout my questions that I've made sure that the equal signs are all lined up nice and neatly. Okay. Another thing, lastly, my variable I see is on the right-hand side. Now normal convention, or the way that we represent things in math is to change that and put the variable on the left-hand side. Will that mean that your answer is wrong? No, it's just it's not as nice, and that's typically how it's done in math. So it's good to get in a good habit of doing that from the get-go. All right, if you feel that these examples made sense to you and you're ready to try the worksheets, you'll see on Google Classroom that I've posted both the worksheets, and I've also posted the answer keys so that you can check your answers. Again, please, 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 please do not guess and check. You need to go through the motions of working out the algebra, the systematic method, so that you know how to manage more challenging questions. Okay, good luck, and please feel free to ask me any questions if you have any. Thank you so much.